non-distribution, we get multigraphs, because you could have a value that's not just 1 or 0, but 2, 3, 4, and so on. So normal distribution, you get weighted graphs, et cetera. And now inside this structure, this notion, so theta for some particular community A and then all other communities, that defines what it means to be in that community. That's the profile distribution of the probability of connecting to other types of groups. So this gives us a way to interpret what comes out of the model, which is nice. I'll show you why that's helpful a bit later. OK. So lots of good properties about this model, especially things that we figured out recently. So it's asymptotically consistent, meaning that if we apply it to data where we know what the answers are, we get those answers back as we get more and more data. It naturally captures lots of large-scale structure, as I suggested. It turns out to be really effective in practice. Even if the assumptions don't exactly match your data, it still does pretty well. And it has lots of nice mathematical features, but especially for my interest, you can augment it with auxiliary data. You can interpret the block matrix for science, and it gives you a natural notion of quantifying uncertainty. Those are the things that I really like. There's been a ton of work in this area in the past 10 years, especially. Here's a selection of papers that I find very interesting. The top one, the binomial SBM, you can see the original date is 83, so many, many years ago. But then most of the other references are 2005 and onward, with a lot more work after 2010. And that's in part because this approach is really sort of catching on. People are discovering that it's a very powerful way of learning from data and being able to do interesting things with it. There's a nice combination of the block model and topic models, which was done a couple of years ago, which I like a lot, especially. And then I'll talk to you a bit more today about some of the stuff at the bottom. OK. So 3 examples of this approach to thinking about networks. 2 of them are very much about developing new methods. And with networks, because it's sort of a new kind of data dealing with these dependencies and relations, developing new methods is essential in order to answer certain questions. The third one, which is an application to understanding gene recombination and malaria,